Arduino has like, I would say 3 or 4 main lines, depending on how you count for them. So one is education, which is the obvious one, which is where we come from and what I personally work with very actively. That is, originally was used to learn and teach about digital technology. And currently it's also used in industrial processes and machinery. The last year I've been collaborating a lot with Luleå University in the north of Sweden. They are involved in a lot of space activities. They're launching missions together with NASA and the Japan Aerospace Agency and so on. Everything from the most mundane kind of like simple machine to very complex scientific cases. Constraints for the first Arduino circuit board came from thinking about how should we think about building a system that will be used by students in class that is very robust and can be reused multiple times, and also is so inexpensive that if you want to leave it inside the object you built, it will just stay there and you can go buy another one. The collaboration with the Roberta editor, for example, is very interesting because Roberta editor brings a standard way of doing block languages for embedded devices. There is a lot of alternatives right now. There's alternatives that are supported by individuals, there's alternatives supported by smaller institutions, but I mean, having one that is actually supported by such a large institution as the Fraunhofer Institute is very good because it offers a certain degree of quality, both at the technical level and on the, let's say, community support level. Also, we have some synergies, like we've got to know that Roberta is really meant for teachers to learn how to teach all digital technologies, which is something that is very much in the Arduino education's mission. So there is a very strong potential synergy there.
We're very proud to say that the Arduino Engineering Kit has been nominated for the Bett Awards this year, so pass by our booth to learn more about it, and wish us luck for tonight.